Hey everybody, this is Larry. This is day 23 of the January Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poem. I have yet another update. I've given up on the old keyboard. It's actually pretty good. It's pretty fine, but it's just a little bit off. And I think what I actually end up wanting is a keyboard that's very similar to what I have on my laptop, because when I travel, I'm going to use my laptop keyboard, right? And I didn't want it to have two different keyboard systems. It messes with me too much. So I actually just end up getting an Apple one. Can you see this? Just got like the expensive Apple one I gave in. I wanted to, do something fancy, but with RGB and all that fancy stuff. But maybe another time, maybe next iteration of when I get a new keyboard. Okay, so hopefully I have fewer typos on this video is what I was going to say. So yeah, today's problem is sequential digits. An integer has sequential digits if each digit has number in the number one more than the previous digit. Okay. The key thing to note here is that I think, is that there are not that many digits, right? What I mean by that is that, like, it can only go up to 9, right? So that means that there's at most 1, 2, 3, let's just say, if I have to guess, there's probably less than 50, or maybe more, less than 55, say, number of total of these sequential digits. And why I say that is that because there's 1, 1, 2, 1, 2, 3, dot, 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 1, 2, 9, right? And then maybe 2, right? 2, 2, 3, 2, 3, 4, dot, 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 2, 3, 4, dot, dot, 9, right? So that means that there's 9 here, 8 here, and then, you do the series, and then it's just the series from 1, the sum from 1 to 9, which is, I guess it's 45, is it? Or I don't know. Whatever it is less than literally, like, well, okay, I was going to say a handful, and literally, but I don't have 45. I don't have that many fingers unless you want to do binary numbers on your fingers. But in any case, it's less than 100, right? Is what I mean. So yeah, so you can actually, what you can do is generate all of them and then do a for loop through them, and that'll be fast enough. And of course, you don't even have to generate it on every input. You can just you can pre-generate, because there's only 50 of them, and then copy and paste the list and then do a for loop, right? So that's basically some of the techniques that you can do and probably will see. The way that I'm going to do it is yeah, I'm going to write the code to generate it for you at home, because it's probably not that interesting, at least for this problem, to be like, hey, here's a list of numbers, do a for loop. I mean, okay. I mean, that is an idea that, especially if you're an interview, definitely bring it up. But of course, they probably still want you to do a little coding. Otherwise, like, what else are you doing with your time, right? So okay, so yeah, let's do gen. Let's do current. Let's just say digit, and then the current number. And then yeah. Okay, so then here we do, let's just say count, total is equal to 0. Let's see, if, so then here what we do is we do something called shift and add, right? Of course, you can kind of visualize what this is, but basically by multiplying by 10, you shift all the digits over to the left by 1 in base 10, and then you add the digit. And of course, the digit should be less than 10 for this to work. Otherwise, it's a little bit awkward, right? So then now you do a gen total plus gen of digit plus 1 and current, the new current. I'm doing this a little bit out of order. That's my bad, and I'm missing some buttons still, so I'm getting a little bit used to it. But yeah, and this is only if digit plus 1 is less than 10. Maybe even a new keyboard I'm missing a lot. So yeah, so that's pretty much the idea. Yeah, and of course this is going to be, oh yeah, that's the other thing that I wanted to do, is if low is equal to right? So I think this is it. Yeah, and then the only other tricky thing is kind of, I don't know if it's tricky, but it's just to make sure you iterate the first digit, right? So for I is in range of from 1 to 10, being 9 inclusive. Total gen of I and I. I think that should be good. Let me make sure that... No, this is a little bit awkward. Actually, current should be 0 because we do the shift and add to the current digit, right? Let me just run it real quick. It's very easy to have off by 1, but that's why we test code, right? So that not everything... Ooh. Huh? That's awkward. Int object not iterable. Is that consistent? 2 is not... Oh, this is a... Oh, wow. My bad. I actually totally misread this one. Or... Because I think I was thinking about the iteration where you have to return the number, the count of these, and not the actual number of these. Okay, so obviously I made some mistakes here, but that's fine. We can just convert this to a list. Right. And then here we can do technically this is actually way more inefficient because we're generating a lot of lists, but we'll overlook that for now because we're having small constants, right? Okay, so I am getting something wrong. Why am I getting something wrong? 1, 2, 3, 4, 5 is not in there. No, it's in there. Do I have to sort it? Oh, I sort it in a different way. Okay. Huh. That's a little bit awkward, actually. But, I mean, we can sort it. Of course, that adds a little bit of some complexity. So I'm doing this way inefficiently, to be honest. But you can actually do this in a better way, right? Like I said, this is only the generation code, so it doesn't have to be that efficient because you're only generating 50 numbers or whatever it is. And then you should pre-process it later or process it later so that you can do it live. Of course, the complexity is going to be low sketch, but everything is relatively constant if you assume that the number of digits is constant and that if it's 10, because they're 10 digits. But let's say you have a different base, right? What does that mean? Let's say that the input is the base is B for whatever you want to play at a higher base, a non-10 base. Then what's the complexity here, right? Well, this is going to be approximately B square total numbers, and of course this actually, I mean, it's a little bit inefficient because of the way we do it. The way that I would actually clean up maybe is just have a global thing so that we don't have to keep on doing these additions, because then now we don't even have to do this. We can just write it like that, and then at the end we sort, say, and of course you can also sort in place, but it's going to be the same idea. Maybe oh, whoops, I don't have a typo per se, but I modified it incorrectly. But yeah, so you can have something like this, right? So that would actually be wrong, apparently, because I forgot to call... Didn't I have a for loop? Why did I take away the for loop? Oops. Man, I'm just being sloppy. Sorry, friends. I said that I got this keyboard so that I don't have fewer typos, but I'm still like being a little bit awkward about it, right? So this should be good. At least in terms of space, it's a little bit better because we don't keep on adding new space. But like I said, this is going to be square numbers, so there's going to be over b squared time, because yeah, and of course you can yeah, I don't know, maybe you could do a little bit better, but yeah, this is over b square space, which is the size of the output, so you cannot really do much faster. And of course this part is going to be some sorting. I don't know if you could do a little... Can you do pre-sorting? you probably could do a little bit pre-sorting. I'm thinking about the processing case, not caring about the low and the highs, to be honest. Because then after you pre-process, this is just a for loop, or it's either a for loop or binary search, but you still need to print out the thing, right? So even with a binary search, you need to print it out, so it's not that much better. I mean, it's better, but it's it's still not the limiting factor. B squared. Yeah, I don't know. If I could do better than that, or can I do better without, or can I do it without the sorting? I don't know. Probably not easily. Maybe you can. I mean, you can do it without the sorting if you do like if you do some sort of like if you have like a linked list type thing and then you do like a BFS, I don't know. Maybe not. Maybe that's just awkward. Because then basically the idea there is that you generate the numbers one digit at a time. So then if you generate all the digits one digit at a time and do it in the right order, you could do it without sorting. But that's way more complex. So that's why I'm going to end here. Let's see what I did last time. Did I do it without sorting? Okay, so in the past I did it without sorting. Oh, I just did it before. Is that true? Oh, yeah, this time. Actually, this is what I said I can do with the effectively breadth first search, or maybe more precisely level order search. Okay, well, past Larry is smarter than I am then. How did I do it the first time? Yeah, the same idea. Okay, so maybe only this time I'm oh no, I sorted. Okay. Yeah, okay. So one time in the past Larry was smarter. So maybe look at this code if you want to double check on how that works. But yeah, that's all I have for this one. Let me know what you think. Yeah, stay good, stay healthy. Hope you have a great rest of the weekend. Contest is coming up for me anyway in about 40 minutes. So good luck to you, good luck to me. I'll see you later. Stay good, stay healthy, take good mental health. Bye bye.